Dear everybody, dear students, my name is Andrei Lee. We are going live and we have to wait another 4 minutes. So wait for that. We wait other students and we will wait for some time. So don't worry, we will start soon. So we are waiting for other participants. 1 minute more and we will start. Whether we will have participants or not, but we will start anyway. So what we are going to be discussing today? Today we're going to be discussing project 2, project 4, complete walkthrough. So I will try to be as accurate as possible, not to break any rules about particular implementations, but you will see particular implementations, but you it's a free material. You are free to mix whatever you want, however you want. So it's up to you, absolutely up to you. So with me this project will be easy. Let's check a Slack channel to see if anybody see this. Let me write down small. No, I think it's fine. Anyway, it's recorded, so we can you can watch it however you want, whatever you want. So anyway, it will be super. So you will enjoy it a lot. So let me start. Uh, while we are waiting, I wanna talk to you about some learning techniques about how to learn. So this is extremely important because it's hard to get this material. Material is very high quality, believe me, because it's written by and produced by scientists, research scientists, real scientists. So first of all, when I saw this material, Udacity, I thought, wow, this is really kind of not organized, I would say. But then when I studied more, it kind of you need a correct frame of mind to get through this, to understand it better. So anyway, material is extremely good. So you will not regret taking it and watching it maybe several times. So how to learn? This is an extremely important question because some people prefer learn start from beginning and end, and they at the end they feel satisfied that everything went fine. They cover through all materials. It's how we are taught to learn, taught to learn in university. Like you have to cover all materials, you have to remember details, and you're cool when you're like, what is it 2 in the power of like 100 millions and so on, and you say answer to the professor and professor is happy. So this is not the case when you go to the work. When you go to work, you need to understand general concepts correctly, like very right. So this is extremely important. What do I recommend you? First of all, try to cover general concept and understand it generally. So it's not bad to watch this material several times. For example, first time you watch, you kind of look through this to get general concept. You look at to get general concept. You know, like the most advanced details, not deep, but details like guns are really important. And for example, like there is a densely connected layer, convolutional layer, a recurrent neural network layer, and GRU and other layers, and you understand the whole concept. You get the intuition. So this is extremely important to understand the intuition behind all these concepts. So you have a sense, you kind of feel what they're talking about, what it is all about. You might get through like if you don't understand, if you like watch this first time and you didn't get it, try to get different materials, like try to Google internet, try to get information from the different perspective, read and read. So I have one student asking me like how to get this wide view on the business, on their neural networks. Read. So the most start with general concepts, but if you reading like try to read all, like simple concept, medium concept, and other things, and there'll gonna be one day boom, and you understand the whole concept. If you understand the whole concept correctly, you're gonna be very professional. Then you go to details, and you know what is detail is connected, because when we learn how we are taught to learn in a school, in university, we are more focused on particular implementations, but no general concept. Some people like start learning like they dig deep. They know that professor will ask this, would ask this, and they try to memorize this, but there is no general concept. And then like for example, computer science course, you pass computer science course and you know nothing at all. So be very careful about this issue. So the second thing I want to tell you is that it's really important to connect things. So for example, you're learning neural networks, okay, and you not only you're getting the general concept, and then you have to go to walk around and see like buses are coming this different ways, like every way is the product of optimization algorithm. Like you wake up in the morning, you go either to the bathroom or to kitchen, there is optimization going on. So your brain is deciding what is the best solution for this particular situation. So like imagine your PyTorch and what as a PyTorch you would do. What solution is the best? So this is extremely important. And I think we are ready to start. So let's start project 2. Project 2, let me go through project 2 and we will start. So first of all, I will what I said is true, and I'm going to cover general concept, then we go to details and we will go through all the details about the project. So what is this what is this generally tricks, and then we go to the live coding session. So as a bonus material, I want to present you like how to create layers for neural network in PyTorch. So this is extremely important material, and you will understand how to create new layers for the neural network. So what general concept also, particular implementations maybe I will share with you later. So, but this is extremely important. This is gonna be booming. This is gonna be very, 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 very hot in a very short time. I think maybe 2020, and everybody will be talking about new layers, and everybody will be looking for specialists that can make a new layer for a neural network. So it's gonna be really, really, really hot. So okay. Okay, I can see people saying me that they want to hear about project 4. So we will go through project 4 for sure. Okay, let's move on. And project 2. There are 6 steps that you have to do. You have to assess phase detector. Code is already pre-written to you. Write dog detector using VGG16. Make CNN from scratch, so you have to create your own architecture. Then transfer learning CNN. This, as we are all PyTorch scholars, and we did have done this task before, so it's not going to be a problem. Write your algorithm. That's pretty easy. There is a trick there, and test your algorithm. So let's move on. Okay, tricks. There are several tricks that you have to be aware of. So first of all, I think it's step number 2. Use map where possible. So map is extremely important. For example, you have a function, phase detector. It's a function. There is an array. There is a list of parameters that you have to feed to phase detector, and you just do map and do this, and it returns true or false, and you will have a list like 0, 1, 1, 0, or whatever you want, and then you sum this and you get the result that you want. So it's significantly better and more effective than have for loops and for loops and for loops, and then a code is long, is slow, and it's not effective. So what do I recommend you generally for algorithm and data structures area is that make your code short, make your code understandable, and use Python built-in functions or methods or classes, whatever you want. So some I found very, 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 very useful to use iter tools. And there are many other tools like product or combinations, and it's very helpful for different tasks. So this is perfect to understand. I will show you code. Don't worry, like don't look like me like I'm going to show you like only a PowerPoint presentation that's over. There's gonna be a code. Second, use image augmentation. This really helps because test data and what do we have? Train, test, and validation data. So validation data, sometimes they're a little rotated, so use rotated, use center crop. It's gonna be very useful. Next, image file load truncated images true. So what is this for? This is for error that appears when you try to feed images to data loader. So in data loader there's gonna be an error that's like images are truncated, and this line helps you cover this problem. Make a shallow network. 3 CNN layers is enough. Linear layers at your choice if you want to make more than 30% test accuracy. So this is extremely important. When I first had done project number 1, there is a particular implementation, and neural network is very shallow. And I thought, oh, Udacity is making like inaccurate, inaccurate recommendation to make shallow neural networks. But then recently I went to the one Chinese very big smartphone producer on an interview, and they said that they need shallow neural networks for their smartphones. So it's extremely important. And what I want to say you, shallow is not bad. Shallow is not bad. It's working fast, really good. So 3 CNN layers, you can do 5 if you want, but I'm generally against of the concept that you have to make like 20 CNN layers, and at the end there's gonna be pixels. And I saw an article saying that after some number of CNN layers they are not effective. So they are not effective after some number, and some people tried assembling, and like after each CNN layer the image is height and width less and less, and at the rest of this nothing almost left. You can go to almost 1 pixel, and that's it. So this is overview analysis. What are the other layers? I don't know. You can do it slowly, like make less iterations and make it like decreasing slower. And but anyway, it's too much details, I think. But maximum, I think, for the usual cases, like 10 CNN layers is enough, in my opinion. If you have some high precision work, so maybe more, but for this task 3 CNN layers is enough. So linear layers, 3 CNN layers are catching the image information, then you have to process it like through the linear layers. And if you want to make more than 30% test accuracy, you can add more linear layers and it will work fine. So what is my process that I went through while doing project 2. So I tried for long like different architectures, deep and other things. I like to experiment, to be more professional, to be more secure, to understand their PyTorch behavior, because there is a particularly important things that you have to understand. They are not written anywhere, unfortunately. And I tried different architectures, but I couldn't reach accuracy more than 10% on the test data. So what was the problem? I tried one thing and other things, and no result. So very slow, like you have to train for 30-40 epochs and no result. Then I tried to remove softmax. So and problem solved. And problem solved, and like in 30 epochs I reached accuracy about 27%, as I remember, or more. The maximum that I reached, it was about 36% on test data. So this is extremely important. And why don't you don't you need to use softmax? Because sometimes you don't need activation function. Like if you make your architecture, sometimes you remove the activation function, it is working. So there are like mainly two reasons for that. First of all, it's because activation like softmax already have included some kind of activation function, and you like doing this job twice. Or sometimes it's work because if you have like linear layer and it's feeding there are particular numbers that softmax is telling your neural network to appear, like from 0 to 1. If you're showing like in your loss function is included, sorry, in loss function there are included activation function, and sometimes loss function is showing like there should be 1 0, but you have like 300 and or more or less, but then later it will fit your neural network, and you will get a correct data from 0 to 1. And I'm usually like, when I have interesting questions, I go to discuss pytorch.org, and there are very smart people there that are knowledgeable, and like about two or three admins that answer all your questions. So whatever question you have, you just can go to the discuss.pytorch.org, and you can find all your answers there. And they recommended me that it's better not to use activation functions. It's like more trendy, I would say trendy, because it works better, it works faster, and other things. So this is a golden article. So if you're waiting for Project 4, wait a minute. There is gonna be interesting information, and this information is here. What do you see? This is the complete solution, complete removal of all your headaches for choosing right learning rate and optimizer. So look at this picture. There are different optimizers and different learning rates. And as you can see, in my experience, the best learning rate is 0.001. But in reality, you can see that it's not the lowest part. 0.001 is like on local maximum. And you can try like between 0.001 and 0.0001. There are good results there. So as you can see, you can find this article here. It's a really good research. I think it's one of the best materials that I ever had in my life. So extremely useful. This man tried different parameters, and as you can see, Adam Optimizer is not bad at all. So it's performing really good, and there are particular numbers for learning rate that you can use. So he tried on one architecture. I don't know, maybe this picture might change for different architectures, but I tried for CNN, RNN, and it's working perfectly. So the number that I have chosen, my magic numbers, are working here because of this great article. So look at disclosure, and there is Adelalta, Adegrat, Adam, GD, Momentum, RMS Prop. So like we are used to use like for reinforcement learning like RMS Prop and other optimizers, but mostly we use Adam, and as we can see, Adam is not a bad choice. So I let you enjoy for some time, and then you move forward. So this article, I will share the presentation, and everything's gonna be very, very interesting. Read it through. I recommend it. Read it through. So this is really, really good, really good. So this is a, I don't know. I want more articles like this that are sharing internals, like what particularly do you need to make your neural network better. So you enjoy this, and we move forward. So next, and in step number 5, I guess you have to write your own algorithm. So this algorithm should be like assess whether it's dog, human face, or neither. So when you use like you have a ready architecture, like I don't remember, it's you have you can use architecture from transfer learning, and there is a problem. There is an output, and how to handle this output. You don't have softmax. Here you can apply softmax. So you do model transfer, feed your image, and then use softmax, and then use threshold, like 30% or more is a dog for sure, and everything's gonna be fine. So you can use numbers. You don't have to adapt to some numbers like 100 is maximum, and then minus 100 is minimum, and then I have to find something in the middle. You will just apply softmax, and everything is good. So everything is perfect. Okay, move forward. I think it's clear. This is a very interesting task. When I first read it, I thought, how do I handle this? How do I get through this? But then later I understood it, and it was really, really, really fun. So people people are watching this. I see activity in the live chat, so you can write me. I can answer you. It's absolutely live. So for those who are watching at 8:23 a.m. Pacific time, it's live. So you can write me, and I will answer your questions. So move to project 4. It's a TV script generation exercise, and what you have to do is you have to generate your RNN. Have to generate scripts, TV scripts. Yes, sure, it's absolutely recorded. I will share the link. So if you have problems with time, no problem at all. So you can find it here. We will look through code, and I will show you my solution. And I won't be fast, don't look at this. This is prohibited by Udacity. So I have some what do I say? Some wish to share with you solution. So and that's it. So first, project 4, step 1, create lookup table. This is very simple. You create lookup table, tokenize punctuation, create tensor dataset, and data loader. So this is the most complicated part of the whole project. I see people struggling with this and making really long code that it's hard to get through. So first of all, I will look at the code at the Slack, because one of my, I would say, colleagues asked me to look at the solution. I will have a look. But what I want to say, if you're doing in Python, PyTorch, please name your variables correctly. I don't don't name it X and Y, G, K. I saw many solutions like IGK, and what is the I, what is the J, what is the K. It's hard to understand. So create tensor dataset, and data loader is the most complicated part. So if you are really lazy and you wanna get through this, that I don't recommend. I was fast and I completed the whole Udacity program, but I wasn't really like hurrying to the end to get the result, to get the certificate, and the certificate only what I want. I want knowledge, and I spent about 260 hours doing this whole Udacity deep learning nano degree. It's a lot of time, so I have some time at my disposal, and I invested this time in doing different projects, Udacity projects, deep learning nano degree. So program is good, and then you create RNN and initialize states. Select hyperparameters. So there's some. If you decide like copy paste and you're absolutely stuck, and you decided to copy paste from Udacity lessons, it's not prohibited. We are allowed to do this because plagiarism states that it's not a plagiarism. So we can surely do this, but there are some parts that are not easy to understand. And we move forward. Next. Okay, first of all, we start from the beginning. I will give you a short overview and then we start from the beginning, like project 4, tricks. So when you, in one of the steps, you have to use counter. You import counter from collections and everything is good. It's like, as I remember, it creates dictionary and like you have a word, for example, Andre, and it 3 times appears. So it making like this dictionary. Again, be careful with tensor dataset and data loader. Check it several times using edge cases, because when I first wrote it, I used provided example and I wrote like 1, 2, 3, 4, 5, 6, 7, 9, and I received 10, and I was happy and everything was fine. But when I ran it, and I was really happy because loss was like way lower than 3.5, and I thought, wow, this is really great. Udacity provided us so easy task to complete because of this. And the reality is that there was an error in tensor dataset, and data loader is not, but tensor dataset is extremely, you have to prepare data for tensor dataset, and this preparation step is extremely important. This is my possible solution. I don't know if you're watching me, the one that wrote on the, I don't want to say names, but if okay, if Joe is watching, this is the solution. I don't recommend it like copy pasting, but to understand it, it's working. If you find the error, please let me know, because it works, and I tried different edge cases and it works perfectly. And as you see, I name variables very easy to understand. So everything is easy and everything is understandable because of right naming of the variables. So this is it. Okay, we move forward, and next. Okay, next. So if connection is good, we are streaming, and okay, everything is good. So because somebody wrote hello, and I was thinking that maybe there is a your code is working. Okay, perfect. Sorry, your code is working. I'm really happy, because be careful. You understand that code is not working when you are when your text is not generating right, when text is not correct. So you will see that like it's repeated words or something. It means that it's not correct. So let me explain you some things. I'm really sorry for calling names. If you're not comfortable with this, please let me know. Okay, loss is not getting any better than 429, 436. Okay, try. I showed article like several slides before about choosing the right learning rate. Try to choose learning rate from the article. It would really help. If it's not getting lower than 429, then no, this loss is not okay, because you need lower than 3.5, as I remember from the rubric. So this is extremely important. Less than 3.5, and you need about okay, I will give you tips. These are my tips, and what we are having here. So when you move forward and try to make your architecture, there's gonna be this statement: weight equal next parenthesis of parameters data. What is it all about? The answer to this is that it's a list of parameters. It's a type of torch and then parameter. Torch and then parameter. Sorry, it's a subclass of torch tensor. Parameter have a special property when used with torch and then module. They're added to the list of parameters. And what are the parameters? It's weights and biases for linear layer, and different layers have different number of parameters. For example, if you have two LSTM layers, and totally you will have, like, if you implement architecture like me, you will have 11 parameters. And first of all, I thought, wow, how does this number appear? And I did little experimenting. Embedding is a 1 parameter, LSTM is 4 parameters per LSTM layer, and linear layer is 2 parameters, weight and bias. Okay. Okay, this is really important. So you have to create a parameter that will be state, and this state is fed to the neural network as an initial. You need initial state to feed to your neural network to start training. So, and this is how it is done. Okay, move forward. This is init hidden. It's a method of class that you name, whatever you name it. Like, for example, RNN. This might be init hidden from your class RNN. Okay, and this is all about what I said. It's creating new parameters, weight new, and define the shape, self and layers, batch size, self hidden dimension. 0 and underscore means that it's in place operations, and it might have CUDA or not. Depends on your architecture, your computer capabilities, and other things. So if you're training in workspace, there is the option available to use CUDA, so use it wisely. Okay, move forward. So and then there is a line LSTM out contiguous. So when I tried to find information about what is contiguous, I didn't get a correct answer because there are so many explanations, and one clear explanation is right on the screen. So when you call contiguous, it actually makes a copy of tensor, so the order of elements would be the same as tensor if the shape created from the scratch. So it's how tensor memory is divided or organized. Because if you want to recreate tensor, there should be particular ordering for some shape, and for example, you might have some data and you want to create it with some shape. So if you create it, it should be particular order in order to create it with the right data. So normally you don't need it, but when there is a runtime error, input is not contiguous, just put contiguous and everything is fine. So look at the Stack Overflow post, it will explain you everything perfectly. Okay, the rest of it, simple. This is a really simple project. Really simple. So if you compare different projects, project 1 is medium difficultness difficulty, and project 2 is more complicated, like complex, and project 4 is easy. Project 5 against you can struggle there for a while, but if you use provided solution and don't invent a wheel, you will be fine. So that's it. And project 7, Amazon AWS. I really enjoyed this. I loved Amazon because there are so many services provided. Okay, sure, Joe. You can ask me. You can dare me. I will try to help you. Okay, this is not the problem. This is not the problem. Okay. Okay. Some people are started project 4. So tips before working on project 4. Okay, what are the tips? Understand RNN. So get the general idea what the RNN is. Like there are 4 gates: remember, learn, forget, and use gate. So understand how they're used. So there are different LSTM architectures, but what is provided is really easy to understand, like way. And what do you need for the most complex part? As I said, is a tensor dataset. So if you want to go like you can try and implement solution, but you can go to HackerRank or LeetCode and like train yourself before moving to tensor dataset, even though it's simpler than most things are not on LeetCode or HackerRank. HackerRank is easy, LeetCode is more complicated, but I strongly recommend you doing these exercises. LeetCode is available by subscription, but there are some free tools. You can run code, you can do exercises, no problem at all. HackerRank I think is absolutely free, so no problem. But I prefer LeetCode. In my opinion, it's better. There are more edge cases, and I tried one exercise, and there were about 300 test cases. So really important. And they test complexity, like ON or ON squared complexity, and you can try to implement fast solution, not only solutions that are working, like, but it's moreover it giving you opportunity to write very effective, very fast solutions with the best experience, and you can look at the people scored in discuss section. And really try to understand their code, and some solutions are really great. So this is my recommendation. And finally, RNN is not a problem, so you can walk through the lessons of RNN, and you can find information there. RNN is not a problem. The only thing is in it hidden. As I said, if you move here, what is this init hidden for? You have to understand, if you starter, that init hidden is to initialize initial state to fit in your LSTM layer. So you need this, and everything, if you implement this, everything's going to be beautiful. So the rest of this is pretty easy. This is easy task, much easier than project number 2 and project number 5. So I want to give you bonus material, but it's not over. So don't leave me. It's not over. I want to give you some bonus material. So how is this all organized? We look through a presentation, and then we go. I will tell you what I want to tell you in this presentation, and then we go to the live session. I have a server running with GPU. Right on my table, along with its notebook, and we will try to complete exercise, and I will show you some code that will make your life even easier. So the bonus material. What is the bonus material? Bonus material is a PyTorch internals and how to create a new type of layer in PyTorch. So I think it's gonna be very, very, very hot in like 2 years or 3 years. Every company would want to make a new layer that are specific to construction, to manufacturing, to finance, and they will be asking for this advanced knowledge of PyTorch, TensorFlow, or Keras. Even though in Keras it might be even more complicated, although it's simple, but PyTorch is ready for this kind of tasks. So I really recommend you PyTorch and over other deep learning frameworks because because documentation is beautiful, because there is a support on discusspytorch.org, and because it's not only telling you how to use it for beginners, like TensorFlow, there is only beginner's guide, but there are advanced tutorials like how to create new layer, how to create a function, how the differentiation work, how autograph works. Like maybe not deep as we want it to be, but it's enough. So let's cover PyTorch internals. It's a very, very interesting topic. Okay, there are two types of components of PyTorch: storage and transforms. What is the storage? Storage is where we store our data. There are two types of storage: storage tensor and torch NN parameter that we talked already recently. And transforms: torch autograph function and torch NN model. What are the difference and what are the applications we will discuss in several in next slides. So storage, torch tensor and torch NN parameter. Okay, torch tensor is just simple multi-dimensional array. We all understand it, we all use it, but under the hood, torch tensor is really complex thing. So I am not sure, but I think in all the internals of torch tensor are hidden in C++ code. And in this C++ code, I think that torch tensor is inherited from autograph. So all the most interesting part of the PyTorch is hidden inside C++ code. I will write an article or give you some webinar with explanation with this code. It's really interesting how it is working. So torch tensor is extremely important, extremely powerful, extremely flexible, and you can do a lot of things with this. It's not limited to deep learning. You can do different optimization tasks and use for this PyTorch. Torch NN parameter, as I said, it's a special purpose structure to add safe intermediary state to your layers. So it's like special thing that you connect to the layer, for layer to have like weight and biases and states included in the layer. So in order to work with them through PyTorch, it's a thing that connected to the layers. So this is what you have to understand. So don't mix image augmentation transforms with PyTorch white transforms. These are different things. So image augmentation, we understand: center crop, rotate, random rotate, and other things. And these transforms are a little bit different. So okay. So what are the transforms? If you have a special tasks, for example, if you have a very interesting idea to implement in PyTorch, like your own algorithm, and you will be happy to see it in PyTorch, it's all working, then you can use its torch autograph function. It's a way to implement functions like torch exp, torch .pov, like to get in power of something. In order to create it, you have to override forward and backward methods to provide a code for forward and backward pass. So what do I mean? This is the function. You define the logic, forward logic in def forward method, and backward logic, your derivatives in backward methods, and that's it. and the whole process of back propagation and forward propagation will be working just fine. So and it's really important because sometimes you need a backward method because your function might be not differentiable, and you need like some simple algorithm to make it like more or less close to the reality. Okay, this is to implement functions, and this is how it's done. You override forward method or backward method, and everything is good. And then the most interesting part, models. With models, you can make own layers of the neural network. So model is a layer. You can make a layer with this, and we are used to use this TorchNN model when we are creating neural networks, but it might be enhanced, and we can write our own logic and use Torch autograph function to implement like different like functions. It might consist not only of the one function, but maybe different functions that you created for usage with your layer. So this is extremely important. And to do this, you have to implement forward behavior. You have to define forward method, and everything will be fine. Okay, move forward. So as I said, market is going to be booming for neural network layers. It's extremely important part because when we had cars sometime, and then the market of tires appear, and then market of different components appear. So it's gonna be happening. This market will grow dramatically, so dramatically that you cannot imagine how it will go. So what I do recommend, like one of the ways we can apply our knowledge is we can work for somebody, but these people will be asking you to have this advanced knowledge of layers, and you have to understand TorchNN model, you have to understand function, Torch autograph function to implement this. It's gonna be very, very hot. Or we can make our own enterprises or small businesses. Like, how do you imagine this? Like PyTorch design studio, India or Russia or USA, to design layers for particular applications. So this is an extremely interesting business, and you can make a lot of money by doing like different businesses that come with this idea. For example, you can create a PyTorch shop to sell layers and other interesting things. So that's it. We move forward. No worries, the most complex projects are projects 2 and 5. The link to project 5 tricks here. It's very short. If you need a webinar, let me know. I will try to make it or pre-record some session, or it will be live. I don't know. As you say. And project 7 is fun and easy. So project 7 is really relaxation, because Amazon AWS is awesome. It's really awesome. And I don't know, in my country, Russia, Amazon AWS is not really popular. But if you live in outside of the world, other sides of the world, like USA, India, China, or I don't know, like Middle Eastern countries, Europe, where Amazon servers are, like how do you call this? They called it availability zones. AZ. Regions. They call it regions, and every region there is availability zone. So in the countries where that are included in these regions, these skills are hot, and there is AWS certification that you can pass in order to get very reliable certifications, but you have to renew it every 2 years. So that's it. Is everybody alive? Okay, and we move forward to the code. So project 2. Okay, we are already like 50 minutes. I like to talk. I like to talk really. Okay, we will try to make it short. So project number 2, for those who struggle. This is extremely simple tasks, and we can say like we know how it's done, like it's not a problem. But when we face this task, there are many subtasks and sub-steps that we have to go through, and it's kind of we run out of QD memory and other things. So let me show you. It's really pretty easy. So in this cell we import NumPy, and we import glob from glob, and this kind of create human files, create nprv glob lfv. It creates a directory structure with files. So we have a list of files in these directories, like one directory, another directory, that's kind of a recursion. And we look at these directories, and there are a list of files. So if you run this, and if you look at the human files, let me show you, it's gonna be a list. Human files, for example, 0. And as you can see, this is a directory to your photo. It's not a path to the photo. It's a complete path to your photo. It's not only the directory. So if you make it like 0 to 10, and we have 10 photos. Okay, this is pretty clear. Then there is the algorithm. It's use OpenCV HAR features, and this is the algorithm. So as you can see, we import a CV2, we import matplotlib, pyplot. It's for simplified plotting, for simple plotting. Matplotlib inline. Then we use cascade classifier. This is a special file that holds particular things, how to recognize images. For example, if it's lines like this, it will recognize lines. Then it recognizes horizontal lines. Then it recognizes like these lines, like backslashes and forward slashes, and other things, and how it is working. So it's usually in XML, and you can find it here. So pretty easy. We read file, we convert it to gray. We detect the from our face cascade file with feature with some algorithm that have this recognition abilities. And then we print number of faces detected. Then we draw a bounding box around the face with these parameters, and then we convert image to RGB for plotting, to it to be colored again, and we show them, and here we have a picture. So face detector, this is a pre-written algorithm. So it reads file, it reads image, convert it to gray, and use detector, and then we can understand whether it's human or not on the picture. So this implementation is pretty simple, and then we move to the next part. First 100 images from human files and dog files, and then we use this kind of a short way to implement this this code. So let me show you. Okay, thank you so much. Thank you so much. It means you're leaving, or you're staying, or you're dying. Okay, sorry. I thought it gonna be like 30 minutes, but it's longer. But I hope this is a interesting material. Okay, we will go through all this. Don't worry. Somebody who is stuck in project 2 will completely make will completely pass this exercise, this project. So we use we use map function. So what do we do here? We have a function face detector that we can find over here. We write this line in map first, and human file short. Human file short is list of path to images, and we get map object that we can iterate through, and it's going to be consisting of 0, 1s, 1, 1, 0, depends on whether human face is detected, and then we apply sum, and we have a total number of pictures of detected human faces on the pictures, and we divide it by 100 to receive % views format. So I strongly recommend you to use this structure because it's short. I saw some crazy solutions with for loop, but use built-in Python libraries to make your code shorter. There are very useful things there, and it will make it fast. It will make you a better specialist, and I hope it will completely change your life at the end. Here's the same logic, and we receive that what percentage of the first 100 images in human files have detected face, 99%, and in doc files 80% of doc images are detected human face on it. So this is pretty simple. Then we implement use pre-trained VGG16 model, and we send it to CUDA. We check if CUDA is available. We send a model to CUDA, and then we do this predicts function. So first we have to use PIL. We import PIL here, and Torch Vision transforms. We load this image, and then using PIL, and then we resize it to 224. So this is my invention, because I thought that it's gonna be faster like this. I did it this way, but you're free to use compose, transforms compose. It's like this. Let me show you. So first we have to execute the code. No, we are not going to execute the code, but the logic is simple. You use transforms compose, and in the list you provide the different transforms, like transforms resize 224, and then another transforms, and so on. So this is a pretty simple idea. Okay, and next we use dog detector. So these images are from 151 to 268. So we check if these images are recognized that fall within this range, and if yes, we return true. It means that dog is detected. So we use this implementation, and the logic is the same as we did before. We use map function, and we use sum to make it. Okay, and then we move forward to optional exercise. The same logic. I implement Inception 101 model. We open image, we get the model, move it to CUDA if available. We make transformations, and then we prepare data for the analysis, and if output is within 151 to 268, but I have to write 269 because last index is not included, we return it, and then we test it, and we receive some results. So results almost or sometimes better than VGG16, so it's pretty clear. So move forward. We already 1 hour. Okay, and here are preparation for the step number 3, create a CNN to classify dog breeds from scratch. So as I said, you have to use shallow networks, and the only problem here is that here is not problem, the only problem is truncated images. You provide this line and everything is going to be good. You will define different transforms for this for train, validation, and test set. And then we move forward to implementation architecture. So this is my architecture that showed about 36% maximum test accuracy. And what else? And we are going to look the logic behind the shape calculation, output shape calculation. So look at this net initializing some parameters, and then we define feed forward behavior, and everything is clear. So convolutional, linear, and then convolutional, max pool 2D, real U, and this 3 times. Then we flatten the output, and then we feed to linear layers. This all linear layers. As you can see, there is no activation function at the end. So there is no activation function, and that's it. So let's make an experiment. Okay, we define this model, and let's look at the shapes. How to calculate shapes of output from convolutional layer. Here is only a convolutional layer, and if you run this, so first we have to use CUDA, otherwise it will argue. Okay, and here we run this cell, and it's gonna take a while running. Okay, it's completed. I have GPU GTX 1050 with 2 gigabytes. Not a lot, but it's enough for me. So then we instantiate our class, our model, import torch, generate random numbers. So first number is batch size, then number of channels, then height and width, as I remember. And this is going to be enough to fit to our model. And then we fit to our model image, and we received result. And as you can see, I printed shapes, and here is the shape to input shape to see convolutional layer is 224 and output 222. So how do we calculate it? There is a formula for calculation. This formula, I is the size of the input neuron, K is the kernel, P is zero padding, and S is stride. So we feed all our parameters 224. As you can see, shape is 224. So here is the output. First it's a batch size. Then 32 is a number over there. 32 channels. And then we calculate this data. So 224 and it becomes 222. And the same logic is here. So how can we do this? So input neuron is 224. And size of the kernel 3, as we can see right over there, kernel size 3, and then size of zero padding. It's you can see this by looking at the function. It's a default value. So if you look at this, padding is 0. Okay. Padding is 0, and we input it in our formula. Padding is 0 and stride is 1. So we move again and look at the formula. Stride is 1. Okay, and we fit everything is in our formula. and we receive 222. 224 minus 3, 221, plus 0 divided by 1, and plus 1, 222, and we have 132, 222, 222, everything is correct. So and then we move to the another part. What's the output of the max pool? I will make it faster because it's already 1 hour, and I don't know whether you are listening to me or you're lying on the floor dead. Write me something like we can hear you and we are still alive to cheer me up a little. Okay, I am gonna be fast. Let me check. Okay, then what's the output of max pool? So first we print what is before and what is after, and before is 222 and output is 55. So how do we get this? We divide 224 by 4 and we receive 55 and with something. So it's gonna be rounded to 55 and it's gonna be your output. So ReLU doesn't change anything, it's gonna be the same. And then we move to, this is a calculation, 224 divided by 4 equal 55, and 55 we have over here. So then there's gonna be a net, another net, where we'll calculate the output size. So here is the input size is 128.7 by 7, and what do? We multiply 108 by 7 and receive 272. So this is the calculation, and that's it. So then we move to linear layers. Linear layers are pretty simple. So if you define this 512, 256, 412, and 133 like number of outputs, output features, because we have 133 types of docs, as I remember. We, as we can see, it's pretty simple. It's number of neurons: 512, 256, 412, 133, and everything is correct. So the rest of it is my writings, and we define optimizer, we define loss function, and then we train. So here is everything simple, usual code. I will try to be faster because it's pretty easy. So we define train loss, validation loss minimum, and then we use for loop to iterate over data. We move data to CUDA if CUDA is available, and then we feed our data to the model, use loss function, then calculate train loss, then we zero gradients, then we calculate derivatives and make an optimization step. Okay, this is pretty easy. This code is provided by Udacity, and there is not much to explain. Here there are used to calculate validation accuracy and training and validation loss. As you can see in this data, loss starts at 4.8 training loss, and I have validation accuracy of 3%, 4%, 6%, 17%, 23%, and 26%. Okay, everything is good. And then we use transfer learning, so we are very aware of this process. So it's pretty simple because we are how did we pass? Because we did the similar exercise. And here's everything simple. We define transforms, we define model architecture, we change the last layer of the neural network, and put our own class, transfer learning in my case. And then we specify loss function, optimizer Adam, 0.00005 is a good learning rate. And then this code is provided by Udacity. We just feed this, execute this code, and finally I got test accuracy of 84%, which is not bad. Okay, then interesting task. Then we have to predict the breed. So here is the little trick. I return class names and output softmax. So for me to have better compatibility with your code, with the code that will be in step 5, write your own algorithm. So here is the run app. I run this app, and if confidence is less than 0.3, I raise exceptions. Neither dog or human are predicted. And then if it's else, if it's face, then we write hello human, you look like, and we provide a dog breed. Then we, if it's not human, we say hello dog, your particular breed. And that's it. That is over. This is my explanation. This is a test. So we feed dog, hello dog, your border terrier, and hello your golden retriever, dog the Bordeaux. Oh no. You look like golden retriever. Hello human, you look like a dog the Bordeaux. And with another phrase, hello you human, you look like wolfhound. And as you see, everything is correct. Dog is recognized as a dog, humans are recognized as humans. And other pictures, I provided buildings, and we raise exception, neither dog or human are predicted. And this is, everything is correct. So pretty easy. Okay, I will, for those who struggle in particular places, I will show you code very slowly from the beginning to the end. So for you to get a better idea what is this all about, for you to get some tricks of some, and get some part of the codes that you might get through in process and make something new and more creative. Okay, we are scrolling down. So we load data, we use VGG16 predict, we use inception, and then we create our own architecture. We specify transforms. Then we create our own CNN. Then there is the testing. This is not important. It's just to show you how the shapes are calculated. And this is my explanation, all my different iterations that I tried, and then training process. These are results, test, and here is the transfer learning exercise. It's transformation, and then the heart of the transfer learning. Then I specify loss and optimizer, and then I predict particular breed and provide class names and softmax output. So I use softmax here, and then this is my algorithm, and here I test my algorithm and it's working perfectly. So completed. Project 2, I hope you will pass. I don't hope, I'm sure that you will pass with this data. So moving to TV script generation. Okay, I will be shorter because I don't want to make you fall asleep. But it's a really interesting exercise. To say it true, I'm a little tired already because it's 1 hour of infinite talk, and but I will try. Maybe I'll have a little rest. Okay, now I'm recovered. Back to the work. Okay, here we have to generate TV scripts, and everything is pretty easy. So here we load the data, Seinfeld, our scripts. Here we explore the data. I will run all the cells. Then we create lookup tables. As I said, use counter here because it's extremely important to use counter. Then this is the code provided. So we run this and all tests, unit tests pass. Then we tokenize punctuation. This is a task for children because it's really easy to do. You just have to type. Process all data and save it in special file. And then we import problem unit tests. And then we move data to GPU. GPU is available. And this is a really important task. Is we define the tensor dataset and data loaders. So we define it here. Everything is easy. And then we load the data. We try to use different cases to test it. Loaded data 1, 2, 3, 5, 4, 6, and for data in loaded data we print data. And let's see, 1, 2, 3 and answer is 4, 2, 3, 4 and answer is 5, 3, 4, 5 and answer is 6. So everything is working perfectly. Then we move to test your data loader. You have to write unit test. Here I wrote my unit test. It's pretty simple. So there are some functions, methods that you have to override, and there are some methods included in the package that you can use to test it. Let's run this. And unit test passed. Run to tests and everything is passed. So everything is working correctly. As you can see, yes, it's working perfectly. Built-in neural network. This is my neural network. Let me explain it briefly. So here we initialize parameters. Here we define feed-forward behavior. Here we initialize init hidden. We define state that we will feed to our LSTM, as far as I remember. Yes, input hidden. Yes, it is correct. So we define vocabulary size, output size, embedding dim, hidden dim, number of layers, and then we instantiate an embedding class and an LSTM, and then drop out linear sigmoid, and we define feed-forward behavior. As I said, the only thing that you have to be careful with here is contiguous. It's used here, over there, and we use dropout, linear connected layer, and everything's gonna be perfect. So then we define forward and back prop. We are very familiar with this code. So it's zero the gradient, input data in the neural network, receive output hidden, loss, backward step, optimizer step, and everything is ready. Okay, then we train RNN. Here is self-explanatory. And then we define sequence length, batch size, and we run our and define other hyperparameters. So try different hyperparameters, don't stop on mine, and loss should be less than 3.5. As I can see, it starts 4.9 and decrease to 3.334 in 20 epochs. This is my iterations that I wrote to the reviewer, and everything is perfect. So here is the code provided by Udacity. We import torch, import helper, and we load the model, And here's the generated text. All this code is provided by Udacity. You don't need to do anything. Jerry, noise. Yeah, that's right, but I don't want it. Yeah, you know what I mean. It's not a little problem. I can't believe this is the last day. You know, I got to be held up. And other things. So, I hope you enjoyed, and let me finish it and show you the last lines. That's it. Complete. Punta. Over. So, I hope you enjoy my live webinar, and I hope to see you again. So, if you need more videos, please let me know. I will try to make webinars and answer all your questions. So thank you very much, and I stop streaming. Bye bye. All good luck.